Well, yeah, welcome to everyone. So now this time, particularly 4 p.m. to 5 p.m. IST, we conduct training on databases. So database development, then after that even data warehousing also probably we start. But right now we are going to conduct training sessions with relational database management systems. Okay. So as far as theory is concerned, plenty of theory is available in the internet. We try to focus more and more on practical aspect. Practically how things work, we try to focus more and more. But wherever needed, we try to, give you information on various terms we use with the database development. Okay. So RDBMS stands for Relational Database Management System. RDBMS stands for Relational Database Management System. Basically, a database is a well organized collection of data or information, so we can retrieve, update, delete, and add new set of data when needed. So, database is nothing but well defined collection of data. When data is defined well and when it is organized in the proper manner, retrieval can be quite fast. Even updation and deletion also instantly you can do it. Okay, so otherwise it becomes very difficult to retrieve data, and even deleting as well as updating also takes a lot of time if the database structure is not well organized. Okay, even when you want to add new set of data in the database, easily it can be appended or it can be added if the database is organized well. Okay, so RDBMS is one such concept. Relational database are one such concept. So whatever commercial applications are available, so which are developed using this RDBMS, relational database concepts are called as relational database management systems. There are many commercial relational database management systems available. So Oracle is one such RDBMS, SQL Server is another RDBMS, MySQL is also an RDBMS. So like this, there are many, say, relational database management systems. Development of RDBMS started all with the IBM DB2. After that, in 1977, first time, in 1977, Oracle actually, the company Oracle, its name was actually Relational Software Incorporation initially. So at that time, they got a project from NASA. So with the project they started, since then actually Oracle has proved itself as a number one RDBMS. So similar to Oracle RDBMS, we have SQL Server or SQL Server. It is from Microsoft. Okay, it's from Microsoft. So it is as good as Oracle, but RDBMS is somewhat, the SQL Server is somewhat cheaper when compared with the, Oracle. So here SQL Server is cheaper in the sense it is not, it's cheaper in the sense here it's not that costly like Oracle software. So the SQL Server is available in different versions, like different versions it's available. Okay, different editions are also available. So similar to SQL Server, we have one more software called as MySQL, which is also a commercial database. Okay, so there is also a commercial database. MySQL and SQL Server are widely used in small and medium level organizations. Okay, but Oracle is used actually with very big organizations. There is a lot of security in Oracle database. Okay, irrespective of actually the prices and irrespective of actually who uses it, all of them implement same concepts. So Oracle, MySQL, SQL Server, all of them implement actually same concepts. Okay, so all these actually tools are called as commercial databases. SQL Server is from Microsoft, Oracle is from Oracle Corporation, and MySQL actually now overtaken by Oracle Corporation. Okay, so MySQL was a free tool. Initially, it was a free tool. It was initially actually free tool, MySQL. So in our sessions, initially we start with SQL Server database. Then after that, we try to cover Oracle as well as MySQL. So as I told you, database management systems are here RDBMS. I need to say RDBMS is relational database management system. So for organizing data, for retrieval, for updation, for deletion, as well as for say insertion of new set of data, we use these commercial tools or commercial applications like Oracle, SQL Server, MySQL. So using them, we can manage our data. With the help of these, you can make your data persisting. You can make your data persisting forever with the help of these tools. Data can be getting persisted using actually these tools. See, your computer program may be manipulating data. You may give data as input. So your program is going to be processing it, you get output. So the output where you are going to save. When your program is running, it's going to be memory. But once you switch off computer, normally what happens? Whatever data you had in the memory, you are going to lose it. To save them permanently, you require some kind of mechanism. So that is going to be organizing data. So data can be organized like files, okay, or like actually something like Excel spreadsheet, or say Lotus 123 spreadsheet, or it can be in some other form. So here database is going to be one such form actually. There you are going to save data in a well organized fashion. So with that, retrieval, updation, deletion, even adding new data can become easy for you. Without much difficulty, you can do it. So RDBMS is actually one such tool, relational database management systems developed by commercial vendors or such tools. So with that, what happens? We can actually maintain our data. Our data can be maintained in a safe and secure manner. Okay. So RDBMS stands for relational database management systems. Here, we store data in the tables. So tables can be connected. One table can be connected with the another table. That's why we call it as actually relational database management system. So here we have the relational tables. One table can be connected with another table. Table is nothing but here it is something like spreadsheet or something like actually something like Excel spreadsheet or say Lotus 123 spreadsheet. Data is going to be organized in the form of rows and columns. So if you try to visualize what a table is, so Excel is an example or Lotus 123 spreadsheet can be an example. So there we save data in the form of rows and columns. We save data in the form of the rows and columns. Before you save any data, you need to first of all define the structure of the table. Then after that, you can put data into the database tables. So first of all, you require structure. So structure meaning is what type of data you want to put into various columns. For each and every column, you need to associate some type of data. Data can exist in different forms. It can be numbers, it can be normal text strings, or it can be in the form of date and time. Okay, so or it may be something like true or false values, or sometimes it may be some image data, or it may be audio data. So that's called a binary format. So in different forms, data can be existing. So whatever type of data you want to put in a particular column, for that column you need to give a type. For example, you want to say some employee number. So for that column you need to make it as numeric. Similarly, if you want to say employee name, you need to give the type to that column as actually string. So like this, you have to save the data in the tables. So more than one table we can have in the database. So using some primary key, foreign key concept, we can be relating one table with another table. That's why we call it as relational database management system. So that's why we call it as relational database management system. Okay. So here we are going to work mostly with the SQL Server initially. After that, we work with Oracle as well as MySQL. So we try to focus more and more on the practical aspect rather than theoretical, because plenty of theory is available on internet. As I told you in the beginning, it's available in the internet. So many books are also available. You can go through them, but working and in gaining practical knowledge is not that easy. So we try to show you more and more examples. Our approach is going to be practical oriented rather than theory oriented. So straight away we delve into the SQL Server now. So as I told you, SQL Server is a commercial database management system. It is a relational database management system which actually stores data in the form of tables. So they can be called as relational tables. So SQL Server is going to run as a Windows service. SQL Server is from Microsoft. SQL Server is going to work, and it works with the say only Windows operating system, or say with Windows family of operating systems. With that, SQL Server is going to work. So either I may say SQL Server or I may say SQL Server, both are same actually. Okay, so SQL Server works with the Windows operating system. Before you install SQL Server, you need to have Windows OS. On top of Windows OS, you can install SQL Server or SQL Server. Okay, so SQL Server is going to run as a Windows service. See, whenever we talk about actually computer applications, the applications can be Windows applications, or they can be web applications, or they can be simply services. Services can be running just in the background. You don't have any user interface for them. You don't have any user interface. In the background, they are going to be running. So here, SQL Server is going to be a service. Like a service, it runs in the background. Okay, so it runs in the background, and it's going to, it normally listens for commands which are sent by the user. So from client, we should send commands to SQL Server. So SQL Server in the background, it processes, then after that it sends the result back to the client. To interact with the SQL Server, we require a client. Without client, you cannot really develop any application, or you cannot use database. So database usage is different, database development is different. Database development is done by the developers. Database is used by all end users. Okay, so SQL Server you need to use along with some application. You cannot use it independently. So just independently you cannot use. Okay, so you have to use this along with some application. It can be a Windows application, or it can be some web application. So using them, and with the help of those applications, you can actually use the SQL Server database. Through application, you may insert data, you may update data, you may delete data, okay, or you may select some data from the database. This is all you need to do with the help of applications. So those applications can be called as user interface. So using user interface, you can be working with the backend database. So in order to get connected to SQL Server, you require a client. So client is required. Without client, you cannot do much with the SQL Server. But as a developer, since you are developing application, some special tools are available to you. Using them, you can access SQL Server database. But once database development is completed, then you need to link the database with the application. With any application, you need to link whatever application requires. So storing its data in the database. So with such applications, you need to link the SQL Server database. Okay. So as a developer, you can actually use SSMS SQL Server Management Studio. With the help of that, we can get connected to SQL Server database. Now let me show you how exactly SSMS is going to look. Okay, so here already I installed SQL Server. Using SQL Server Management Studio, I can get connected to SQL Server database. Okay, if you don't have already installed the SQL Server in your system, you can download the SQL Server Express edition from Microsoft site, then you can install. Okay, you need to download SQL Server Express edition and you can install in your system. Okay, so if you bought the SQL Server, so SQL Server has different editions: Express edition, then probably a professional edition, standard edition, then you have actually enterprise edition. Depending on your requirement, you need to choose different versions. Of course, as far as SQL Server functionality is concerned, you have few differences. SQL Express may not be having all the features like an enterprise edition, but mostly whenever you are learning SQL Server database development, that is going to be sufficient for you. When you develop something, when you use production database, in such cases you require enterprise edition or some standard or professional editions. Otherwise, when you are learning at the time, you can just use express edition. With the help of that, most of the SQL Server topics can be learned. Okay, so using SQL Server Management Studio, I can get connected to database. To get connected to SQL Server database, I require this particular tool. So with the help of this tool, I can be getting connected. So let me click on this. It actually gives this user interface for me. It's giving this kind of user interface. To get connected to SQL Server, I require here some server name, then followed by I need to choose some type of authentication, either Windows authentication or SQL Server authentication. Okay. See, whenever you install SQL Server, at that time you need to choose what type of authentication you need, whether it is Windows authentication or you want to use mixed mode authentication. So when you use mixed mode authentication, in such cases you can do with the SQL Server authentication also. But if you choose only Windows authentication, you need to use always Windows authentication only. So using this, you get connected to database. Whenever it is Windows authenticated one, you don't require separate user ID and password. With whatever user ID and password you log into your system when you started your Windows operating system, whatever credentials you pass it, so same credentials can be used automatically here in the case of Windows authentication. So this kind of authentication you can use whenever your application and database, that is SQL Server, are in the same system. Physically when they are in the same computer, you can choose such kind of option, Windows authentication. Okay, but whenever your database is in a remote computer, probably it's in the LAN or somewhere in the remote location, in such cases you definitely have to go with the mixed mode authentication. So while installing itself, you need to choose mixed mode authentication. With that, you can install the SQL Server database. So you can use mixed mode authentication. At that time, you require actually user ID and password. Username you need to provide, either as password you need to provide, then you can get connected. When you choose here SQL Server authentication. But now I am not using any SQL Server authentication, just I use Windows authentication, using which I get connected. Okay, now let me get connected to here SQL Server database. So successfully I could get connected to this, and whenever it's successfully getting connected, it can show some user interface for us this way. So it is just like actually any other IDE. Like IDE stands for Integrated Development Environment. Just like any other IDE, it's looking here. So on the top you have actually, it is also a window in fact. Here you have a title, and in the left side you have an icon here. Okay, so then similarly you can minimize this, you can resize, and you can close. And just below that you have a menu, that's file menu, edit menu, view menu, debug, tools, window, community, help. So every Windows application has this. Every Windows application must have a menu. Okay, so similarly here one more menu is available. It is specific to the SQL Server here. Now you can look at the Object Explorer. So in the SQL Server, data is going to be organized in the form of databases. Databases contain tables. Tables are going to be containing rows. So further rows are divided into columns. Like that we maintain databases. Apart from tables, we have different types of other databases. Different types of objects. Apart from the tables, we have different types of other objects also in that. Like views you have. Okay, like procedures, triggers. Okay. Similarly, you can be having functions. All these can be called as different types of database objects. Database is collection of here various objects. Okay, when I expand, you can find here different types of objects in this. First of all, it's showing all the databases which I created. So whatever database I created, here they are available. Now when I just expand here TMPDB, it is showing many things like database diagrams, tables, views, synonyms, programmability, service broker, storage, security. So like this, it's showing various objects for us. These can be different objects. So here you can have database diagrams. It is entity relationship diagrams you can maintain in this. It is going to be collection of tables, collection of views, Synonyms are nothing but permanent aliases for various objects. Okay. Under programmability, you can have procedures, functions. So like this, here database is nothing but collection of different objects. Those objects can be, as I told, tables, they can be views, they can be synonyms, they can be triggers, they can be functions, they can be procedures. Okay, so like this, we have different types of objects in the database. A database is nothing but collection of those objects. Fine. So here, this is what Object Explorer we say. It is nothing but here Object Explorer. This is called as here Object Explorer. And apart from that, we have many other things like security, then server objects, replication, and management. We will be discussing about these as we progress. So just we are looking at the user interface. When I click on the new query, it is going to show a query editor window. I click on the new query, it shows here a new query editor window. Okay, whenever you want to manipulate the database, either you can give commands from here or you can choose the GUI. So using Object Explorer and using graphical user interface, you can actually manage the SQL Server database. So here you can use SQL commands. SQL stands for Structured Query Language. SQL stands for Structured Query Language. So using SQL commands also you can manipulate database, you can manage database. Or else you can use here Object Explorer using graphical user interface also you can do. So but my sincere advice here is always try to use the commands. Just try to type commands in the query analyzer window. So using this using commands, SQL commands, try to manipulate database. Okay, you need to manipulate database with the help of commands. That's a good practice instead of using GUI. Of course, using GUI you can do it much fast when compared with typing commands here. But when you type commands, you get complete hold over the SQL. You'll be getting good command over the SQL. So for practicing with SQL, try to use this query analyzer window. So with the help of that, try to type commands, then try to execute those commands rather than using actually the GUI. So using GUI also, as I told, we can do it, but try to use always commands only. First let me show you how to use GUI to create various objects. So as I told you, the database is a top level object. Okay, so within the database only other objects we can create. So tables are the very important objects because they only hold the data for us. Data we put into tables. So data we are going to put in the tables. So that is very important object in the database. Apart from the tables, we have many other things like views, then triggers, then functions, procedures, synonyms we said. Like this we have different types of objects. First of all, let us create a sample DB. I create here sample DB using GUI, using graphical user interface. I am going to create here. So this is just a demo of all the things. So it's not everything, we are not going to complete like this. I am trying to give some overview on this. Okay, so after that we revisit all these things and the proper I try to give you very good idea on all these things. Okay, but right now what I am doing, I am trying to show you something with the GUI. Now I create using GUI some database. Click on this, then click here new database. Okay, so I am going to create a new database. Already we have few databases available here like AdventureWorks 2008 R2, AdventureWorks DW 2008 R2, database with FG, Dushyant DB, EMP DB, Example DB. So all these are nothing but previously created databases. And here Aladi-PC SQL Express 2008, it's called as this Aladi-PC is computer name and SQL Express 2008 is actually instance name. Okay, so here this is the name of the instance name of the SQL server. Like this number of SQL server instances you can have in the same computer. Okay, number of SQL server instances you can have, but with the different names you should have. Instance is nothing but an SQL server copy, that is. A instance is nothing but SQL server copy. As many copies as you want you can have. Of course there is some limitation, say some up to 100 instances you can have in the machine. Okay, so to find out how many exactly you can have, you need to go through the SQL server documentation. Okay, so with that only you can understand exactly how many instances you can make. Fine. Now here, this is what exactly the server name followed by instance name. With this we are trying to, we open the instance, and in this instance we are managing the databases. And this instance is what exactly? It's a Windows authenticated one. It's not mixed code authenticated. So this is only Windows authenticated. To access this instance, you don't require separate user ID and password. So whatever user ID and password you have used it to log in into Windows, same credentials you can automatically get applied to open this particular instance. So here you have different databases like AdventureWorks, then Dushyant DB, EMPDB, Example DB. All these are previously created ones. Okay, and apart from that, we have here one important folder called as system databases. But we can say it as folder, or we can say it as tab. Okay, so this I call as here folder. So in this folder, you have 4 different databases: a master database, model database, MSDB, and tempDB. Okay, so these are the databases available for us here. You have master database, model database, MSDB, tempDB. So as soon as you create an instance of SQL Server, as soon as you install SQL Server instance, these automatically get created for you. Master, model, MSDB, and tempDB. These are called as system databases. You should not tamper with these databases. You should not tamper with these databases. We should not touch at all these. A master database, a model database, MSDB, and tempDB. So why we use master, model, MSDB, tempDB, I'll explain you later. But right now, these are called as here system databases. They are made for the system. For this particular instance only it is. If you tamper with these, the instance becomes actually non-operable. So you cannot use in such cases the instance. So therefore, be careful with the system databases. Now here you have other databases like AdventureWorks, then EMPDB, Example DB, Product DB, Publisher DB. All these are previously created databases. Now let me create here a database. A new database I would like to create here. So I should give here some database name for that purpose. I am going to give some database name. The database name is going to be sample DB. Give like this. I am going to write it as sample DB. This is the database name. Okay, DBO, database owner, is going to be the schema name. Automatically it's going to be getting applied as DBO. So whenever you create any SQL Server database, a minimum of 2 different files they get created. One is sample DB, other thing is here sample DB underscore log. These 2 files they are getting created. First one is called as MDF file, other one is a LDF file. So MDF stands for here master data file. Then this is going to be LDF is nothing but log data file. Here all log information we have. So this is what sample database. Initially its size is going to be 2 MB. The size of the sample DB is going to be 2 MB here. After that automatically it increases by 1 MB. So here initial size is 2 MB, auto growth is going to be 1 MB. What is this? Whenever you create a file, normally with normal files we never specify any size and we never say anything like auto growth. Then what it is? Okay. Further, where exactly it's getting saved? It's getting saved in this particular default location. In the default location, it's getting here created. The file is getting created. If you want to choose different location, you can choose it. Okay. So first thing is what here? File group is going to be primary and initial size is how much here? 2 MB. See, data in the SQL Server is going to be organized in the form of pages. Okay. Each and every page size is going to be 8 KB. The page size is going to be 8 KB. So like that, 8 different pages is called as one extent. So one extent equal to how many pages? That is 8 pages. 8 8s are 64. So 64 KB is going to be one extent. Like that we have. Okay. So in the form of pages, we are going to be maintaining it. Now say for example 2 MB. When you say 2 MB, how many pages there are going to be? 1 MB equal to 1024 KB. So 2 MB is going to be 2048 MB. When you divide 2048 with 8, how much you get? 2048 divided by 8. So 8 2s are 16. Okay, so 8 5s are 40. Then followed by, so 8 5s are 40. So 8 2s are 16. Then followed by 8 2s are 16. Let me calculate here. So it is going to be like calc. I using calc. I can calculate. So this is total. How much this is? This is going to be 2 MB means 2048 KB. 2048 KB, that is 2048 we take, then we divide with the 8. So therefore how many pages this is going to be for us? It's going to be 256 pages they are getting created. So whenever the SQL server is reading data, writing data in the form of pages only, it's going to be writing. It's going to write in the form of pages. So because of that, it is set here some initial size. Then after that it's saying auto growth. That means what? Whenever it does not find enough space, automatically it creates actually 128 pages. Since it's 1 MB growth, it's going to be 128 pages they are going to be getting created. Okay, so this is what sample DB. This contains data. Data is organized in the form of pages, and pages further we can make with them the extents. One extent equal to 8 pages. And 1 page equal to how many KB? 8 KB. So therefore 1 extent equal to 64 KB, like the data is maintained. And similarly here it's creating log file. So log file contains actually summary of all your transactions. Whatever transactions you are doing with the database, all of them are recorded in the log file. Okay, so the database name is what here? The name is here sample DB. So with this now I am trying to create a database called as sample DB. So once I create sample DB, inside that I can create other objects. I can create other objects inside that. So this is what exactly sample DB is going to be the name of the database. Okay, so initially its size is 2 MB. After that by 1 MB it's going to increase. Whenever the computer or SQL server is not finding enough space with the given file, it increases by 1 MB. Then as far as log files are concerned, it's 1 MB. Whenever it falls short of memory or in the file, therefore by how much it increases? By 10%. That means what? Every time it's going to be increasing by 1024. It's like 100 KB. Approximately you can think as 100 KB will be getting allocated every time whenever it's falling short of memory in the file. So it increases by 100 KB. So like this it's creating for us files. And one other thing is here collation. So if you go with the options, it shows you somewhere collation. So collation is what here? Server default. It is actually server default. It's using here default collation. So it's going to use actually American English. Then collation is going to be case insensitive. Collation basically used for cultural information. That means cultural information means what? From country to country the culture changes. Culture is going to be changing from country to country. For example, you take datetime data. So in the case of datetime data, in America we use actually MMDDYY notation. But when it comes to Britain or if you come to India, we use DDMMYY notation. So similar to that here, the collation part also we are going to be using. In the case of collation, see, we can make the collation as case sensitive or case insensitive. So that is going to be very much useful in the case of searching. Whenever you are searching data, so whether it's case sensitive or case insensitive, depending on that, search results can appear. So therefore collation is going to be very important. This collation feature is going to be more and more useful in the case of say ideographic languages, particularly with the CJK, Chinese, Japanese and Korean. In such cases it will be really useful. Okay, so collation, all that further we discuss as we proceed further. So here we are going to create a new database now. We create database, new database. Now what happens here? It's creating for us a new database. Now you can see in the bottom the sample DB. We can see now here sample DB database. But when you expand it, you cannot find any tables inside this. Expand it. It may have system tables, but otherwise there are no user defined tables. We don't have any user defined table in this sample DB. Okay, apart from the tables, you have views, synonyms, programmability. When you come into views, probably certain views are available here for us. It's called a system views. It is expanding here. We are getting so many views. From where these views are coming? We have seen in the system databases a database called as model DB. We have a model database. So from the model database, all these are getting copied. So these system views are getting copied from the model database. A view is nothing but a logical window to the table, we can say. It's a view to the logical view to the database table, that is normally called as a view. So using view, you can select only portion of data from the given table. Apart from that, you have many other features also in the views, but just I am saying it can be logical window. So using that, you can be retrieving data, portion of data from the given table. So that's going to be view. So here system views, they are getting copied from the model database. Similarly, when you go into programmability, you can find here few system stored procedures. They are nothing but predefined stored procedures. They are available here. So mostly related to administration, we can use these. Similarly, we have here functions. See, all these are nothing but system stored procedures. Okay, and apart from that, here I show you here functions. So functions are also available for us. Functions are nothing but actually these are predefined functions only. All these are predefined. Those predefined we are going to use. These are nothing but actually for helping purpose. Suppose you want to find out some square root. Yourself writing that code can be difficult. So all these are nothing but library of functions. So SQRT, with the help of that you can find out a square root. Similarly, sometimes you have to generate a random number. So using random function you can do it. So all these are actually helper features available with the SQL Server database. These days, every software vendor is giving you helper features. Helper classes we say, helper methods we say, helper functions we say. So that way you can use. These can be used for meeting certain requirements. Writing yourself code for finding out square root is really very difficult. Similarly, you need to go with actually you have to generate sometimes a random number. So writing that code can be difficult. So therefore, using existing libraries, you can actually work. So they are called as library of functions. So like this, these functions are available here. They are also getting copied from the model database. These are getting copied from the model database. So like this, the model DB is going to be useful to us. Model DB is going to be useful. It's going to supply the initial required features to the user created databases. So whatever features are required for the user created database, they are getting copied from the model database. So model database is going to be therefore very important database for us. We should not tamper with the system databases. So what happened here? We created here a database called as SampleDB. We created here SampleDB. So now let me create some table in this. I want to create some table here now in this. So table, as I told you, you can think it as a it's nothing but set of rows and columns. So every row contains certain number of columns. Same number of columns are repeated for every row. So for every row, same columns are getting repeated. So when you define a table, you are going to define the columns. So when you define a table here, you are going to define a structure of columns. That means what columns are required in the given rows. So that we are going to define. Now I want to make some kind of database. So using that, I can save data for a retail outlet. For a retail outlet, I can save data. Normally, whenever we work with retail outlets, so in the retail outlets, we have various products. We have various products in the retail outlets. So these products are categorized. You find many categories also. You have so many categories under them. Okay. Similarly, in products, so when you take a particular category, under the category there can be number of products. So there can be number of products. So we are going to categorize products with the help of categories. Products can be one entity, categories can be one entity. So in the categories we maintain category information, under the products we maintain products information along with the category information. Similarly, we have customers. Okay, we maintain the customer's information. Similarly, we have sales information as well as item sales information. So all this information we need to maintain, and apart from that, we need to maintain here customer history as well as product history. So we have here customer history and one more is here product history. Okay, so this database I want to create. It should be, the database should be holding all these data: products data, categories data, customers data, sales data, item sales data, customer history as well as product history. So here categories and products are going to be master tables, I can say, because seldom they get changed, seldom new things are added to them. So once in a while only to them we are going to add new items into that. Initially we need to populate them, initially we need to add number of products, number of categories. After that, seldom we are going to modify them. But customers can be every day new customers may be getting added to us. Every day you can add new customers. Again, customers also can be used as here master data sometimes. Now for example, take sales. So sales are going to be repeating, every day sales take place. So sales can be called as here transaction table. Similarly, item sales also can be transaction. Customer history if you take. So customer history also may not change, seldom it changes. So customer history is going to contain entire customer information. Customer today, he may be living in one locality and the person may be having one mobile number today, but tomorrow that can be changing. So location can change, the phone number also can be changing. Such things we are going to record. So whenever the customer is changing the location or mobile number, automatically a new entry will be made into customer history. Similarly with the product history. So why we require product history? What can be changing in the product history is the price of the product. So prices change very much regularly, probably on daily basis, on weekly basis or on monthly basis, or whenever there is a necessity in change in price, that will be getting changed. So whenever price is changing, we need to maintain its history. Product history we need to maintain. So initially I thought that these are required to maintain the retailer DB. So retailer DB is basically for retail outlets. So for them we need to create these tables: a products table, a category table, a customer table, a sales table, item sales table, customer history table and a product history table. And these can be called as here logical. We can say this as logical. I am saying just about products. Okay, and these can be called as also entities. One entity can be connected to another entity. How these can be connected? See, every product must be belonging to one of the categories. Every product should be belonging to one of the categories, and under one category there can be n products. So relationship is going to be here one to many. One category, under one category you can have number of products. So under one category you can have number of products. Therefore it is going to be one to many relationship. This can be called as here one to many relationship. One category ID may be used with number of products there. Okay. Similarly, you take customers, and there is a relationship between customers and the customer history, customers and sales. So every sale you need to make with some customer only. So same customer may be, repeatedly coming and buying things. So therefore, customer can be here, say a table, that you can link with the sales. This is also one to many relationship. That is also going to be one to many relationship. Similarly, when you talk about sales, so under sales there can be number of items. For example, you take one sale. So the sale may be say some $150 or $200, but you can be buying under that sales number of items. So each and every item also you should record, because if you take an item code, how many pieces you are going to buy, what is the amount they are going to pay, actual amount is how much discount is given, all that you need to track. So therefore here item sales is going to be many, but sales ID is going to be one. So between sales and item sales the relationship is going to be one to many. Similarly, you take product and you take product history, here also it can be one to many, because in the product history table we maintain the information of same product multiple times. Why we put multiple times? Whenever there is a change in the price, automatically we add that as a new entry to the product history. Similarly, you take customers and customer history. There also what happens whenever customer address is getting changed or phone number is getting changed. So what we do there? We actually record new entry. We are going to make a new record will be added there. So therefore, that is also going to be one-to-many relationship. So like this, we are going to make the tables, and here these can be called as relational tables. Okay. Now, very first entity what I want to design is here category. Okay, I don't use plural, I am going to use only singular. I say this as category. So whenever I say category, it's going to have these attributes. A cat ID we say. Then similarly cat name. Cat ID stands for category ID, and other one is here cat name. I have a category name. Then I have here a cat level. It can be a cat level. Then other thing is super cat ID. Like this I can have here. So if you take a category, the category may be top level category, or it can be subcategory, or it can be under another subcategory. So like that we are going to maintain data. So it's category table. In the category table we have a cat ID, we have a cat name, we have cat level, we have a category ID. So this is called as here conceptual model. This is here logical model, and this is going to be here conceptual model. So I am just talking about category entity. It's category ID, category name, category level, and super cat ID. Similarly, I go with the products. When I go with the products, here it's a product ID, put like this, then product name, write like this, then product name, this is price, I put here, followed by cat ID. So I can join these two tables now. Based on the category ID, I can be joining. So between category and product, therefore it's going to be one-to-many relationship here. So whatever cat ID is available here, we definitely should have here. So otherwise, product should not be getting added. This can be sometimes null, it can be missing value. Okay, this can be missing value, but whenever you enter any value, the value must be available within the category table. So it should be existing as cat ID, then only it should accept. If you don't have any value, just you can have a null value, it can be missing value. So like this you can be maintaining here referential integrity. So we can have here referential integrity with the help of the primary key, foreign key relationship. You can think cat ID is primary key here, and here product ID is going to be primary key, and here cat ID is going to be here a foreign key. Even in the category table also this is going to be a foreign key. So like this we maintain. In the category table, super cat ID is going to be referring cat ID. But when it's product table, cat ID is going to be referring actually category table cat ID. So like this we maintain. So these are called as here two entities, and when I define these entities here, a cat ID, cat name, cat level, super cat ID I am saying, similarly product ID, product name, price and cat ID I am saying, but I haven't said anything about the data types here, how physically I am going to save them. I did not say that. So this is what exactly conceptual model. Now I go with the physical model. When I go with the physical model, how exactly I am going to save data, that comes under actually physical model. Okay, so how it's going to be getting saved? What is the name of the table? Name of the table is going to be category, I put it. But cat ID, when you talk about cat ID, what type of data that is? Is it a string, or is it number, or is it date type, or is it any unique ID, or is it true or false value? What type of data it is? I haven't said anything. So we need to have some ID for the cat ID now. Sorry, we need to have some data for the cat ID. Some type is required. So therefore, here in the category table, I have like cat ID. This I want to make as integer type of data. It's going to be numeric data. Cat name. In the case of cat name, this I want to make as varchar. Varchar is nothing but some string. It is some string. Similarly, we take cat level. Cat level can be here again integer, because it can be 0, it can be 1, it can be 2, it can be 3, like that we take it. Similarly, supercat ID also here, supercat ID also going to be int. Like this, now I try to give some shape for the data in the table. So whenever you create category table, it takes category ID, category name, category level, supercat ID. So these attributes, they are going to describe the entity. Entity is what exactly? Category is nothing but entity, but using these attributes, we are going to describe here the entity called as category. a cat ID. With the help of that you can identify a row in this. Okay. Similarly, cat name, with the help of that you can find the name of the category. Cat level, using this, at what level in the category hierarchy you can find out. Super cat ID is going to give you under what main category you have this subcategory. If at all it is subcategory, this is not going to be null. So if it is not any subcategory, if it is top level category, in such case this can be a null value. So like this you can have here category entity. Similarly, when you talk about product ID is going to be numeric data, integer type of data. Product name is going to be say string or varchar type of data. Price is going to be again numeric data. Cat ID is going to be numeric data. So like this we can create. So these are called as here entities. We can say them as entity. But now, so whenever you say the logical as well as conceptual, we use there the like entity, and other thing is what attribute we say. But whenever you work with physical, you need to say it as a table. We need to say this as table, and these are going to be columns. Okay, these are going to be columns for us. So let me create a table now in this. I am going to create a table. For that, here what I do, I can click on the tables here, a new table. Like this, when I click on this, it's going to give me some user interface. It's giving some user interface for me. Here I type now the column name. What is the name of the column? That is going to be cat ID. I put like cat ID. Type of data is what? This is going to be int. It is going to be integer type of data. Put like this. We don't allow nulls. Okay. Next thing is what? Cat name. I write like this. This is cat name. Then this one is varchar. What is exactly varchar? I'll explain later. So varchar of 50. Then here other one cat level. This is going to be cat level, and here it is int. This is integer type of data. One more is here supercat ID. Put like this supercat ID. Then this is again int. Like this, physically I am going to create a table. I am going to create table. Cat ID, cat name, cat level, supercat ID. Now cat ID I want to make as a primary key. Just I want to make this as a primary key. So for that purpose I can click on this set primary key. Cat ID is made as primary key now. Similarly, if I come to cat level, by default it should take a 0. So default meaning is when you don't enter any value, automatically that value must be taken. Default value or binding here under column properties I can set. This is going to be 0. When you don't enter any value, that is going to be 0. And similarly, supercat ID, with the help of this you can link the cat ID. So that is going to be primary key, foreign key linking in the same table. In the same table also we can link, that is going to be here supercat ID. Okay, so for that purpose I can click here. Then I go to the relationships. Under relationships, click on add here, close it. Let us say first of all, say this as category. I give a name as category. Then here try to create a relationship. Click on the relationships here. Now expand the tables and column specifications. Okay, we expand like this. Click on this here. Now choose a category table, and this is cat ID. And foreign key table also category only. Here we choose supercat ID. We are linking the same table with itself. The table with itself we are linking. So this is called as self-linking. We created here primary key, foreign key relationship. We created here a primary key, foreign key relationship between the same table. So here we created now a table called as category table. We have created here a category table. So now into this you can insert data. You can insert data into this. For that you click on this, then go with the select top 1000 rows or edit top 200 rows. By clicking on this you can insert data. So here right now there is no data available for you. Okay, so cat ID you enter some 100 or you can put 1000, followed by here you put toys. Okay, cat level, if you don't specify anything, that can be 0. Now coming to this, automatically 0 is getting added because we have given there it as 0. Next 1001 we give, and here cat name is here we say this electronic toys. Okay, it's electronic toys. So here I want to give it as level 1. Category level is going to be 1 because it is coming under toys. Toys is going to be 1000 under that particular category. Since it's coming, it's going to be here a subcategory. Like this we made it. There are two data now. One is what? 1000 category ID. Cat name is going to be toys here. Cat level is 0. Super cat ID is null. Similarly, when you take 1001, here it's cat ID, and this is going to be electronic toys. Cat name is cat level is 1, and here super cat ID is 1000. That means electronic toys come under toys, and its level is also 1. Here see, for the toys the level is 0. For the electronic toys it's going to be 1. So like this we are going to maintain super category and subcategory. Now suppose you want to see this particular table data. So for that purpose, again I can come to the TBL category, right click on this, then here say select top 1000 rows. It's going to show data in the bottom. It's showing data for us like this: cat ID, cat name, cat level, super cat ID. Then second one also 1001, electronic toys 1 and 1000. So this is exactly what creation of a database table, creation of database, and we put some data into the database table here. Okay, so here today, therefore what we have done, I gave an introduction of RDBMS here, I gave an introduction of SQL Server, then here we created a simple database called a sample database here, then in that we created a table and we discussed about actually conceptual, logical and physical things. So what exactly conceptual model and physical model, and similarly logical model, what exactly they are, we discussed even on that. Okay, so tomorrow further we are going to be doing more with the SQL Server database. Overall I give an idea what is exactly the SQL Server is, what is RDBMS, similarly what is this IDE, what is SSMS SQL Server Management Studio, so what are actually system database in this. I just gave you a brief idea on that. Tomorrow further we are going to discuss about how to download SQL Server, SQL Server, how to download SQL Server version, then how to install it on your system. I am going to demonstrate it to you. Similarly, I am going to share one link with you, so using that link also you can install yourself